So this gentleman on the left is Isaac Newton, and we're going to look at three of his laws in this topic. Now, we're going to look at his first law first, and that first law states that a moving object will continue to move at the same speed and direction unless an external force acts upon it. And his first law also says a stationary object, that means staying still, will remain at rest unless an external force acts upon it. So basically, if all forces are balanced or there's no forces acting at all, something will either continue moving at the same speed or it will stay still. If there's an extra force or a resultant force acting on an object, it'll either start to move or change the speed or direction it is already moving. So we're going to look at three examples here just to put Newton's first law into practice. Our first example, example A, is a ball with a velocity of 0 meters per second, so it's stationary or it's at rest. And we can see from the diagram there's a 5 Newton force acting to the right, a 5 Newton force acting to the left. Remember from the previous lecture, to calculate the resultant force, the opposite direction, you subtract them from one each other. So the resultant force is 0 newtons, so no direction. And Newton's first law states that this object, because all the forces are balanced, will stay at rest. If we look at example B, we can see we've got a ball that is starting at rest, but now we have a resultant force of 8 newtons to the right. So this counts as our external force. This is a resultant force acting upon this object. So this object is not going to stay at rest, it is going to accelerate to the right. If we look at example C, we've now got a ball that is already in motion. It's moving at 2 meters per second, let's say, to the right. If we look at the resultant force on this object, we've got 15 acting to the right, 3 newtons acting to the left, so we have a resultant force of 12 newtons to the right, which means this ball is going to accelerate to the right. So it's not going to stay at 2 meters per second, it's going to increase its velocity in that direction, so it might continue to accelerate. We'll look at how to calculate acceleration in a later lecture. So we'll just look at an example of a rocket now. We're going to think both horizontal and vertical directions. So horizontally, I'm going to say this rocket has no velocity. It's going at 0 meters per second in the horizontal direction. And we can see that there's a 10 Newton force acting to the right, a 10 Newton force acting to the left. Those forces are balanced. There is no resultant force horizontally. So it will continue to have 0 meters per second horizontal velocity because the forces are balanced. However, if we look at the vertical forces, we can see that there's a 20,000 Newton upthrust force, a 200 newtons drag force, so our resultant force vertically actually ends up at 18,000 newtons. So this goes against Newton's first law because there is an external force, so it's not going to stay at a constant vertical velocity, it's going to accelerate in the upwards direction.